what lies at the centre, and I'll be careful with my language, what lies at the centre of a black hole. Now just in Einstein's general theory of relativity, actually it's not right to talk about the centre of a black hole, really. So what are we picturing? It's this thing called a singularity. You might think of it as an infinitely dense point to which this massive star collapses. It's kind of the natural way to think of it. But actually, just even in pure general relativity, when you look at a nice map of a black hole, the so-called Penrose diagram named after Roger Penrose, what you see is that the singularity is not really a place in space at all. It's a moment in time. And actually, it's the end of time. So one way of picturing what's happened when a star collapses to form a black hole is that space and time are so distorted that, in a sense, their roles swap. And so what we thought of as an infinitely dense point, a place in space, a singularity. But the nature of that thing was not, and is still not, understood. So that's a great mystery. And it's been long accepted that we will need a so-called quantum theory of gravity, a deeper theory of gravity, in order to explain the singularity. And for many, many years, actually, until quite recently, then people thought, well, there we are, we have a problem with the singularity, we don't really have any access to it, we don't have the conceptual tools to explore it, so it may remain a mystery for a century to come. It's not clear what to do. The great revolution in black hole research was to notice, and it began with Stephen Hawking's work in the mid-1970s, was to notice that actually there are conceptual problems at the event horizon of the black hole. Not in this extreme place, not only in this extreme place, at the singularity, whatever that might be, but at the horizon. Now that was a real challenge and extremely interesting, because we strongly expect the laws of nature that we understand now, laws of nature that we have full mathematical and conceptual control of, to apply at the event horizon. And so that's why black holes have become so interesting. It's because we have a place where we think, we assume, and indeed we're right to assume, it seems, that we have full control of the physics. We understand what's happening, but there is a fundamental clash of principle between our two basic theories of nature, general relativity and quantum mechanics. And that is ultimately why the event horizon of a black hole and black holes themselves have become so fascinating and so important.